What I want to talk about today is the idea of a limit. And it's pretty important to understand this because it's the basis of what you're going to be doing in your calculus course. So, the limit, what does it mean? A limit is basically a way to say that as one variable approaches a limiting value, so let me just sort of sketch here. So let's say I want to say as x approaches 2, right? So this is my 2 here. As x approaches 2 on this function is y equals to x cubed minus x. So as x approaches 2, what is the value? What is the output? So the way you write a limit is basically lim, and then below it, you put the variable that you're stating as it is approaching 2. So as x is approaching 2. And let's just say y. So you write the function, and then this is the limit. So again, just to reiterate, it's just all about as something is approaching one variable. So let's say as x is approaching some variable a, what is it getting closer and closer to? What is the output, basically? It's not necessarily going to equal the output, but it's like getting extremely close to it. So in this case, as it gets closer and closer to 2, what is it going to be? So as it gets in smaller and smaller and smaller and smaller and gets closer and closer and closer, it's going to be 6, right? Because it's getting infinitely smaller. And if that doesn't make sense, like think about it. You can put it in your calculator. You can try. Let's say you had 1.9999 cubed minus 1.9999, right? And you can put that in your calculator and it'll find that, well, it equals to 6 because you have so many 999s that your calculator will just round. But we're assuming that as it gets, infinitely smaller to that, it's never going to equal 2. This is not the same as equaling 2. It does not equal 2. It's just getting very, 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 very close to 2. So as it gets very, 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 very close to 2, it's going to equal 6. So that's the idea. It's just all about as it is approaching something. And we're going to see the use of this quite often in this course. So that's basically the idea. I hope that made sense. It's just, again, as you approach one variable, you're getting closer and closer to 2, and eventually the output will be the same as if it was just like, if x equals to 2, what is the output? It's sort of like that. So let's do another example. Let's say I wanted to find, I'll do this in a different color, 3, and right over there. Okay. So this is just the function y equals x squared. What is the limit of x approaches to 3 of, we'll call this y again. Usually you would write f of x. So what is the limit? You can pause the video, try it yourself. Okay, I'm assuming you paused it and you tried it. So as it is approaching 3, so this right here, that's 3. If we count, that's 9. So as it is approaching on this function from both sides, as it is approaching this, as it's getting closer and closer to 3, what is going to be the output? Well, we can see it's just 9, right? And maybe I can just write x squared here to make it make sense more, right? So actually, if you're doing this algebraically, what you'd be doing is you'd actually just be plugging in the value. You'd just be like, okay. So I know it can be a little confusing. You think, oh, this means x equals 3. No, it doesn't. It means as x is approaching 3. Because it could be like 2.9999999. And that's very close to 3, right? So again, sort of make that, comparison clear in your head that it's not equaling 3. It's just getting super close to 3. Let's try another example. All right, here we have the function, and I'll do this in another color. Y equals 1 over x. So Another great thing about limits is you can also break them up. So you can do something called a left-handed limit. So let me write that in here. You can do something called a left-handed limit. And also a right-handed limit. So with a left-handed limit, so with either or, what you're doing is you're basically splitting up the limit. So a left-handed limit means coming from the left, as it says, left. And then a right-handed limit means coming from the right. So the way you would write this is, let's say, we'll just represent it as A. Let's say limit, actually no, I'll just write it. So we'll say limit as x approaches, we're going to say 0, right? So we'll say as x approaches 0 from the left. So in order to say from the left, you put this little exponent looking thingy, like a superscript of just a minus sign. It's not 0 to the negative. It's just indicating, this is just a convention to indicate that it's coming from the left. And if you were doing a right-handed limit, you would just write limit as x approaches whatever value, it doesn't have to be 0, from the right, positive. And this sort of makes sense because the left-hand side of the Cartesian plane tends to be negative, right? The negative x-axis. And then from the right-hand side, there's a positive x-axis, right? So positive and negative land. So this is negative land. This is positive land. So as x approaches from negative land, what is this going to equal? So if we put 1 over x here, 1 over x here. So the idea, so some functions don't necessarily give you a nice value. Some of them diverge. So what we saw in these previous examples, like this one with x squared, it was converging to a specific value, right? This was also converging to a specific value. But with here, we're diverging actually, because we know if you put in 0 over 1 over x, you get something called undefined. So there's a little asymptote right here on y equals 0, right? Sorry, x equals 0, not y equals 0. So there's a little asymptote. So as the limit of x approaches 0 from the left, we're going to look at this this part of the function, right? Because these are both the same function, right? This is just, again, 1 over x. We're going to look at this part, and we can see that it keeps going down, 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 down. And so it can go down forever. It's never going to really meet it. Again, x is just approaching 0 from the left. It's never going to equal 0. So this would just be negative infinity, because we can see it's going down, down, down. This function can continue going down, down, down forever. And so that's just going to be negative infinity. And then with the right-handed limit, similar idea, except now it's going up. So we're going to look at this guy. Maybe I should just box this up to show the direction. So looking at this guy, we can see it's increasing and increasing, increasing as x approaches to 0 from the right. It's just eventually going to equal positive infinity. So I hope that makes sense. So I'll just write this on the side. Some will, some will diverge. So some, that's not a nice bright color. I'll just keep it in yellow. Some can diverge, which means they move away. So they're like staying away from either an asymptote. So staying away from an asymptote, or they oscillate. So for an oscillation example would be y equals to sine x, because that, if we draw a quick little sketch here, that guy goes like this, and it'll keep on going like that, till as x approaches infinity, it'll keep going too fast. So the limit is undefined. Limit is undefined when x approaches infinity. You can find the limit as when it approaches a certain value, like here, 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 but as it goes to infinity. So that's, oscillation. And then the asymptote one, the idea of diverging, we can see right here in this reciprocal function. So now we took the left hand and right hand limit of this reciprocal function. What if I asked you for the general limit? What is the general limit? So the normal limit we did for the first two examples, as x approaches 0 for 1 over x. What's the limit? Pause the video and see if you can think about it. So this was a trick question. There is no limit. This limit does not exist. And here's why. If you look at what we did with the right hand and left hand, as x is approaching 0 from the left, it equals negative infinity. When x is approaching 0 from the right, it equals positive infinity. In order to determine the existence of a limit, so I'm going to say the limit of x, let's say, approaches a from the negative, f of x equals to alpha, right? Just like a very general statement. And the limit of x approaches a from f of x should equal the same thing, alpha. So if from the left-hand side it equals the same value, and from the right-hand side it equals the same value, therefore limit of x approaches a of f of x exists. So basically, there cannot be a limit if the left-hand side limit and the right-hand side limit don't agree. If they don't equal each other, then there is no limit. And like we see with this reciprocal function, right? From the left, it's negative infinity. From the right, it's positive infinity. So there's no way for an actual limit to exist. So you can write this down or memorize this, but that's basically the idea. There's no actual limit that exists. You can take the right hand and the left hand limit, but again, no like general limit per se. So that's the basic idea. Moving on to some basic stuff. In the next video, I'm going to be talking about just how to do a lot of this stuff, algebraically. So there's some limited properties you need to know when you're doing your calculations. So I wrote for the first one already. So the limit of x approaches a for k times f of x, where k is a constant. K is a constant. And so basically, when you have a constant multiplying by an actual function with its variables and stuff, you can just factor out the k because the limit won't do anything to it. It's just a constant value. The other one we have is the limit of x approaches a, where f of x, you're adding it to g of x. What you would do really is you're just taking the limit of each one and then add it. Of g of x. So that's basically all you're going to see when you're going to notice a trend with all of these where you're just taking the limit before and then following with the operation. So with the limit of f of x times g of x, just take the limit of f of x and then multiply it by the limit of g of x. Take the limit before and then follow through with the operation. Same thing with here, limit of x of a of f of x divided by the limit of x approaches a g of x. And then I'm sure you've sort of gotten the grip by now, hopefully, of this, but same thing. Limit of x approaches a g of x. So these are the limit properties. You're always just taking the limit before, then you're just following through with the operation. So just to recap, we went over these examples. What is a limit? A limit is basically as x or as some variable approaches its limiting value, what are you getting really close to in terms of the output? And so it's not equaling, that limiting value. It's just getting so close. And then what's the output value? We saw that with this example, again, the idea not equaling the value. And then we saw the idea of left-handed limit and right-handed limit. So we can take a limit from the left-hand side or the right-hand side. And if they don't agree with each other, then there is no general limit. So if they don't equal the same thing, there's no general limit. And this function, particularly with y equals 1 over x, is an example of a diverging limit. it can either equal to like infinity or some other value, or it can just be undefined. Like for example, we saw y equals sine x. So, oh, sorry, I said some other value. No, either infinity or just undefined. My apologies. And that's pretty much it.